Hey there, pre-cal kids. Today we are going to look at 4.5a. We are going to look at tangent and its brother-in-law cotangent. Some fun facts about tangent that you might not know. Well, it's equal to tan. Here is the noteworthy stuff, guys. Whatever I highlight is going to be noteworthy. Your domain is going to be all reals except for odd multiples of pi over 2. And we'll talk about what that means. Okay? Your range is always going to be all reals. Okay? And your vertical asymptotes are x equals k times pi over 2 for odd integers of 2. There's an infinite number of vertical asymptotes. They go on forever. Okay? Like if this is pi over 2, this is an asymptote. And then odd integers, so 1, 3 pi over 2. Dot, dot, dot. Let's go through and actually draw a picture. Some more stuff about tangent, guys. Noteworthy page. All of it. All of it. Okay. So if we're looking at f of x equals tan x, which is the same thing as sine over cosine. This is important to keep in your head. Because if you ever forget, well, where are my vertical asymptotes? Well, your vertical asymptotes are wherever cosine equals 0. Okay, because you can't divide by 0. Guess where cosine 0? Yeah, pi over 2. 3 pi over 2. Yes, I would draw this picture and label these negative pi over 2. Negative 3 pi over 2. If you go a little bit further, 5 pi over 2 would be your asymptotes. Okay? And how do you know where the zeros are? Well, that's easy. Wherever sine equals 0. If you knew your unit circle, you remember that cosine is your x value, and x is 0 at pi over 2, and 3 pi over 2, and you knew that sine is your y value, and that's 0 at, well, 0, pi, 2 pi, 3 pi, 4 pi, so on, so on, so on, so on, so on. Okay, 0, pi, negative pi. Okay? Can please graph this, guys. In your period of this beast is pi. It repeats every pi. Unlike sine and cosine, they're every 2 pi. Every pi. You see 0 pi, 2 pi, 3 pi, 4 pi. It repeats every pi. Okay? Trivia question for you. What's Mr. Toolator's favorite flavor of pie? Okay? So when we shift things on this graph, we're going to look at the zeros and the asymptotes, guys. Ready for more? More? This is all noteworthy. All of it. Okay, guys. So you have sum y equals a times tangent of your b times x minus h plus k. It's the same as sinusoids. A is your stretch or shrink. If a is greater than 1, it's a stretch. If a is greater than 0 but less than 1, it's a shrink. The constant b affects the period. Now this is different than sine cosine because your period now is just pi over b. Not 2 pi over b, just pi. H is a horizontal translation. K is the... This is the same stuff we've been dealing with these two guys. But we do not use the term phase shift and amplitude. Okay. Let's take a look at our good friend cotangent. Cotangent way to spell. Cotangent looks just like tangent, but here's the noteworthy stuff, guys. The asymptotes are the zeros of sine, the cotangent are the zeros of cosine. So you flip-flop your asymptotes and your zeros with cotangent, okay? Because remember, cotangent then is what? A quick review. If that's sine over cosine, cotangent is cosine of x over sine. Okay? And you can see here's my graph of cosine. Wherever I hit a 0, it's my 0. Here, wherever I hit my 0, is an asymptote. You got it? Get it? Good. Let's do an example. Describe the graph of a given function in terms of basic trend out function. Locate vertical asymptotes and graph 4 periods of the function. Okay. Start off with an XY chart. Now, remember, what's this negative do? Bye. Guys, you should know this is noteworthy, even if you just put this and graph it. The negative tells me I'm going to flip over x-axis. Okay. What's this 2 tell me? This tells me my period is going to be pi over 2, because I take pi divided by my b. And that's all I'm going to change. So, my first starting point is still 0, 0, because that's where tangent is 0. Look, look. Look, look, look. 0, 0. And we aren't shifting up, down, left, right, okay? So that's my first 0. Now my period is pi over 2. Okay? So that means every pi over 2 I'm going to repeat. So that's going to be another dot, right? Here's another dot. Right? And let's go pi over 2 this way. It's negative pi over 2. This would just be pi, guys, because what's pi over 2 plus pi over 2 is pi. Okay. Now, here's what I got to think about. Where are my asymptotes going to be? If pi over 2 is my period, right? That means this distance is going to be pi over 2. So I cut that in half to get how far over I'm going. So it's pi over 4. So this is going to be pi over 4. It's going to be negative pi over 4. And this is going to be an asymptote. Okay. Okay. Now every pi over 2, I have an asymptote. So we go pi over 4, pi over, so right here would be 1. Right here would be 1. And we need 4 of them, right? So I'll go over here would be 1. Okay. Now, remember, normal tangent looks like this, right? And we're flipped. So it's going to go like this. It's going to look like cotangent. Okay? So when I draw it, kind of looks like that. And like that. Kind of like that. Like that. Ta-da! It's our graph, guys. Oops, missed it. But you guys got it. Okay. So vertical asymptotes. They're going to be at First one's at pi over 4. So see pi over 4 plus k times k pi over 2. Because they repeat every pi over 2. You keep adding pi over 2 to it. Okay? Period's pi over 4 or 2. Vertical asymptote, you find your first one, and then you add period. This is k times your period. Okay? So it's your first one plus k times your period. Oh man, this one's tough. Okay. 3 tells you that it is a vertical stretch. So I'm going to be honest, you can't do much about with these when you sketch them. Okay? This divided by 2 tells me that pi divided by 1/2, which equals 2 pi, is my period. Okay? And this 1 is a vertical translation up. Up 1. Okay? Let's do this thing. Start with my XY axis. It's actually not bad. Okay? Now, I know I'm going to start at 0, 1, guys, because, well, I'm sorry, get back here. It's cotangent, so be careful. Let's go back. Where's cotangent start? Cotangent starts at pi over 2. Okay? So it starts at 0 pi over, or pi over 2 0. So we still go over pi over 2, right? I'm sorry. Okay. Here we go. I know what's going on. Where does our cotangent asymptote start? At 0, right? And you don't, no matter what you times that by, it's still 0. So we have an asymptote right here at 0. Right? Now where's my next asymptote going to be? Well, my period's 2 pi. So I go over 2 pi. And that's going to be my next asymptote. Right? Then I go over 2 more pi. That's my next asymptote. Because that's my period. That's when it repeats, guys. So I can go over negative 2 pi. That's my asymptote. Okay? I guess I gotta do one more just for fun. Go over 2 more pi. 6 pi. That's my asymptote, right? Now, to find out my starting point, what's the point between 0 and 2 pi? Well, this is pi, right? 3 pi, 4 pi, 5 pi. You silly me. Negative pi. Okay, so we go to our normal starting point, but we're going to start up 1 because that translation, right? Now, cotangent starts up. I missed. You just make that bigger. There you go. That's our graph, boys and girls. One more. Okay. And then our vertical asymptotes. Our first one's at 0, right? So 0 plus, what's your period? 2 pi k. So you don't even need the 0. It's just 2 pi times some number. Okay? That's it. Enjoy. By the way, this last example is noteworthy. Everything's noteworthy, guys. just watch videos.